final exam part 1, first full question. Yeah. FQ10 power series number 1. Okay. Yeah, because for this part, it's very easy. The computation could be very hard. Yeah. So I tried to make equation to do not make it too hard when you do the computation. Yeah. So here I choose these numbers. Yeah. First, for the ODE left-hand side, I skip. Yeah. So I intentionally skip that y prime term. Yeah. Because y prime term, if I add that, then your computation pretty much you double the computation. Yeah, that's a lot. You pretty much you double your computation. Yeah. So you need double the time. Yeah. So I remove that, then much easier. Yeah. So look at the solution. First, we need to write y in a power series representation. Yeah. So this general representation. Okay. Yeah. All right. Then after that, we need to take a derivative. Yeah. The first derivative, yeah. So each term derivative. Yeah. Be careful. The m, the number starting from 1. Yeah, not 0. Yeah, 0 because that term is gone. Derivative, the constant, it's gone. Okay, from 1. All right. Then, yeah, because that 4y, yeah, we just prepared constant 4 times y here for our next round computation. Okay, all right. Then double prime. On the derivative, we take prime another time. Yeah, the power rule derivative. Yeah, this time m start from 2. Yeah. So 0, 1, all gone. Yeah, all 0. So all gone. Okay. Yeah. So m starting from 2. Yeah. But m starting from 2 here, there is one thing. When you want to add those two terms up, add those two expressions up. Here, x to the m, here, x to the m minus 2. Not the same. So you want to convert the power of x term, this term, the same degree. Okay, same degree, so you can add them up directly. Yeah. All right. Then, so this step, I hope you can understand easily. All right. So we change. Yeah. So actually, we use a special, so here, we can use a special variable substitution, but here, I just, for example, you can think about, we use m prime, or m tilde, m prime, hopefully not confused with derivative. M tilde, for example, m tilde to represent the m minus 2, that if you use m tilde, when m equals 2, m tilde equals 0. Here you all use m tilde, but after we make the change, we want to go back to m, because tilde, something extra. We want to make it as simple as possible. So after the substitution, then we go back to the original m. Yeah. So here, okay? So try to understand this step, this change. Okay? Yeah, because if you make this change, when we add these two summation up, it's much easier. It's much easier. Yeah. So can you get this step? Yeah, yeah. I hope if you need me more explanation, yeah. Try to get this step. Yeah. All right. Otherwise, try your best to understand this step. Yeah. So otherwise, you just take the summation. Okay. Yeah. So when we do solve question, you just take it. Yeah. All right. But I believe you can understand. Okay. Understand the notation change. All right. Then we can add them up. But when we add them up, you can see there are two parts regarding the m, two parts, because the right-hand side, 1 plus 2x plus 3x squared. When m equals 0, 2, 1, we need to use these terms. But when m greater or equal to 3, we won't have these terms. We just do direct equal to 0. Okay? These terms gone. So we split into two parts. Yeah. The first part, we consider m equals 0, 1, 2. 0, 1, 2. 3 cases. Yeah. All right. M equals 0. We plug in m equal to 0. These two equations add up. M, you plug in 0. 0 here. 2 times A2, right? 0 plus 2. 2 times A2 plus 4 times A0 equals the x to the 0 coefficient. That's 1. 1, x to the 0. So that's the first equation. Okay? Yeah. Then you plug in m equals 1. M equals 1. Here, 1. 6 times A3 plus 4 times A1 equals the coefficient of the x term. Yeah. So, yeah, second equation. Second equation, right? Then third equation, m equals 2. 2 plus 2, 4. 4 times 3, 12. 12 times A4 plus 4 times A2 equals 3 here. Okay? All right. So that's the first 3 special cases. Yeah. After that, then our general case. Yeah. Our general case. So we split 2 parts. Okay? All right. All right. Therefore, m greater or equal to 3. Yeah. So we only need to write 1 general case. Yeah, because we can handle the same way. Yeah, same way. All right, m greater or equal to 3. Yeah, take just these two. The same term, the coefficients adding together equal to 0. Yeah, equal to 0. Yeah, then we can write a sub m plus 2 equals negative 4 over m plus 2 times m plus 1 times a sub m. Yeah. So this is true. This is true for all m greater or equal to 3. Okay. Yeah. All right. So after this preparation, our next slide, we are ready to calculate all these a coefficients, all these little a coefficients. Yeah. Our home question easier than this one. Homework, I only give you 2 x terms. Okay, you don't have the third, so yeah, slightly easier than this one. Yeah. All right, and you don't have that 4. Okay, also easier than this one. Okay. All right, continue. So next one. Yeah. So let me copy. From the first equation, you find a2 equals 1/2 minus 2 times a0. Okay, first equation. Second equation, you can write a3 equals 1/3 minus 2/3 times a1. Okay, all right. The third equation, a4 equals 1/4 minus 1/3 times a2. Okay, all right. Yeah, yeah. But here, after this, this simplification, yeah, so we write A2, A3, A4, yeah, all right, then, yeah, we try to simplify, yeah, so when we solve a question like this, we try to make it as simple as possible, yeah. All right, yeah, how to make it simpler, yeah. Read the question, all right, original. Apply the power series method to find a particular solution for the ODE. Okay? I only ask you to write one particular solution. I do not ask you to write general, solution. Or one particular solution. Yeah. Because one particular solution is important. If you can write one particular solution, then we know the general solution of this homogeneous. Then we can write general solution easily, right? Yeah. So So we don't worry about that general part. We only need one particular solution. If one particular solution, we have freedom to choose the first two coefficients, right? A0, because A0 determines A2, A1 determines A3, and so on. Okay? Yeah. Based on that requirement, we just assume, we choose the simplest case, we assume A0 equals A1 equals 0 to make it as simple as possible. No. Yeah. Because we know A0, A1, the non-zero cases will be included in the general solution of this homogeneous equation, right? That's the non-zero case. Yeah. So here we don't worry about. We throw away, some important part. No, yeah. So if we want to get them back, we can solve the homogeneous equation. Cosine sine, right? Yeah, cosine sine, you will get A0, A1 back. Yeah. So, but here we don't need that part, okay? So we make A1, A0. So there we can get, because for particular solution we can get a simpler A2 just the 1/2, okay? A3 just 1/3, A4 just, because you need to plug in A2 equals 1/2, okay? 1/3 times 1/2, 1/4 minus 1/6, that's 1/12, A4. So after you have these first three numbers, the remaining, we have our general recursion, right? So this is general recursive formula. All right, so A5, you plug in, you get -1/15. Okay, A6, you plug in, you get here. All right, so because we cannot calculate forever, right? We have to stop somewhere. Yeah. So for me, if you for the general formula, if you calculate 2, that's enough. Okay. Yeah. So in your homework, the general case, you just calculate first two coefficients for this general case, then I treat as good enough. Okay, because if you need more, we can rely on computer to generate all the remaining, right? So in the real world situation, we can use computer, write program to produce all the remaining coefficients, right? As many as we want. Yeah. So for your work, so that's good enough. So I know, so you know how to calculate. Yeah. So you know the procedure. So that's good enough. Okay? Yeah. Just only give me the first two terms in the general case. Now we are ready to write the final solution. Yeah. The solution, because A0, A1, 0, it's gone. The first two terms gone. So then we write, all these coefficients. Yeah. We put together. Yeah. A2, A3, A4, A5, A6, and so on. Okay. Yeah. That's the final solution. That's a particular solution. Okay. Yeah. And here we assume, with the help of computer programs, we can get any number of terms we like. Okay? Yeah. So it's not a problem. Yeah. This ... no problem. If we do not have, so here, even if we do not have the explicit formula, I do not require you giving me the explicit formula. Yeah. Sometimes, if the formula is easy to get, then you can write a formula, right? But for this case, the formula may not be that easy to get, right? Yeah. So that I do not require. I do not require you give me the formula like that. Okay, it's not necessary. Yeah. If you look at our textbook, some of the solution, the textbook just to give us concrete numbers like this. Yeah. Sometimes we can get a formula like that. Sometimes we don't have explicit formula, so we take it. Okay? If we cannot get explicit formula like that, we just take these concrete numbers. Yeah. Yeah. Still, no problem. Yeah. All right, that's the first problem. Yeah. Yeah. So here you can see, 2 slides, this much work. After you do this much work, so you practice. Okay, you practice doing the calculation like that. Yeah. So that I may like to see. So in next week training session, I want to see if you can do similar questions in 5 minutes. Okay, I can give you 2 terms, not 3 terms. 3 terms, you do 1 more. Okay, you know 1 more equation. So here, you just do 2 equations. Yeah, I change different numbers. So after some practice, can you get this final particular solution within 5 minutes? Yeah, let's see how hard it is. Okay? Yeah. 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 All right. Yeah. Second question. I changed to this one. Yeah. The structure is similar, but I changed some numbers. I try to, get some appropriate numbers. Yeah. All right. So let's look at let's recall the Frobenius method. Yeah. This method. What's the meaning of this method? Yeah. The Frobenius method, actually basically the power series, we know when we use the power series to represent our solution, there is one special case. One special case. Our first method we couldn't cover. So the Frobenius method tells us we can use x to the r times a0 plus a power series x and so on. And that r not necessarily integer. Okay? It is allowed to be a real number. Yeah. There, our previous method, because our previous method, we assume the power series in this way. So that case does not include this special case. So the Frobenius method, we can cover this special case. Yeah. All right. Yeah. Now, for this equation, then we need to use the Frobenius method. Our old method, won't work well. Okay? Yeah. Yeah. All right. So here, because the structure, let me do step by step to explain the structure. Yeah. All right. First, because for the Frobenius method here, we take this form, x squared, x, so then multiply x, more convenient. When we do the, power series expansion, so this version a little more convenient. Okay, all right, all right. So then here, after we write this version, because there is a theorem, all right. So we need to calculate initial equation. There is, just like characteristic equation, but this place we call initial equation. There are 3 cases, okay? The Frobenius method, there are 3 cases, but for us, I only ask you to do the case 1. We don't do case 2, case 3, okay? So this is case 1, okay? So you only need to focus on case 1. So homework, we practice case 1. So final, we work on case 1. We forget case 2, case 3. Okay? Yeah, don't worry. Save time. All right, so what's the case 1 here? Because if we look at the roots of the initial equation, we can see the case 1, the roots. Okay, all right. So here, the roots, so what's the B0, C0? B0, so here, you look at the coefficient, because this x, you do not look at the x, because, so here, the form is x squared y double prime plus x times bx y prime plus c x y equals 0. Okay, so the form. So after you take away that x, you have a b power series expansion. That B0 in your power series expansion, that's the B0, okay? That's the B0. C, yeah, so after this is the C, okay? C0, that number, okay? B0, C0. B0, when you look at the B0, you need to skip 1x. Yeah. Take it out. 1x, take 1x out. Then B, right? So do not include, if x is B0, 0, then it's wrong, okay? Then it's wrong. So, yeah. The reason why we take x, later you will see, because this term expression, they will match, okay? They will match later when we do computation. They match, there is 1 degree difference, okay? 1 degree difference. So we make up the difference part, okay? We make up the difference part. So then, that's the reason you need to take away 1x, okay? You look at a B0, so C0, okay? All right, yeah. So that's the reason, B0, C0. Because the initial equation, we need to use B0, C0, okay? Initial equation, yeah. Yeah, otherwise, you may write the initial equation wrong, right? Yeah. So, all right. Then, you just solve this initial equation, plug in the numbers, solve it. You get 2 roots. The first one, 1/3. Second one, R2, 5/6. Yeah. Here, I intentionally use non-integer roots. Okay. If integer roots, then we go back to our previous power series case, right? If you have integer roots, that's nothing new, right? Yeah, we don't need the Frobenius method. Okay. So here, I intentionally make questions. You will have fraction roots. So then you have to use the power series. You have to use the Frobenius method. Okay. All right. That case 1. Now, what's case 1? I didn't remember. The difference of these 2 roots is not integer. That's case 1. Okay. The difference is integer, then we have case 3. Yeah, case 3, so the form will be different, right? So here, when I make make your questions, I just choose the difference is non-integer. Yeah, so you don't worry about the case 3, okay? All right, yeah, all right. Yeah. Then, all right, yeah, yeah. Then, look at this title. Find a solution. I do not need you to find all solutions, right? Just give me 1 solution. Then it's good enough. 1 solution. How about we take R1? We don't need to calculate R2. Right? R1 give, because you plug in R1, you get 1 solution. Plug in R2, another solution, right? You just do R1. When you choose relatively simpler one, right? Relatively simpler one, okay? Yeah. So you can reduce your computation by 1/2. Yeah, right? Yeah, like that. Yeah, because I just check if you can solve the problem, right? So I do not want you, spend a lot of time on something not important. Yeah. Yeah. All right? Yeah. So let's do R1. Yeah. R1. This time, you need to write that y, okay, with this one. But it's not convenient to take derivative like that. So we like to expand in this kind of, separate terms. Yeah, because there's a product. Then when you apply the derivative product rule, very messy, right? Yeah. So we like this way. We calculate derivative, so a little easier, right? The first derivative, each term, yeah, this time you need to calculate the first derivative, okay? The power rule, yeah. All right, you need to calculate another second derivative another time. Yeah, here a little harder, all right? Yeah, so hope you still. So here, what I need, so here, look at the 1, 2, 3, 4. If you calculate 4 terms, it's good enough. Okay? Yeah. Yeah. Do not calculate more than 4. Okay? Yeah. 4 terms, good enough. Okay? Yeah. 4 terms. All right. Yeah. All right. Yeah. Give you a little time. Copy. Yeah. All right. Yeah. So the next slide, we just do, pure computation. Yeah. So just be careful. Yeah. All right. Yeah. Yeah. So be careful. Yeah. There. Yeah. Yeah. So the fraction here, I try to make it not too bad for you. Okay. Yeah. I mean. Yeah. Yeah. Definitely our homework question easier than this here. Yeah. Homework, our one half easier than 1/3. Yeah. Homework, so it's not too bad for your homework questions. Yeah. Yeah. So for final, if I can make a 1/2, yeah, that would be good. Yeah. So 1/2. The simplest fraction. Yeah, simplest fraction 1/2. Yeah. All right. Oh, sorry. Yeah, hope you follow later. Yeah. Then, yeah, let's just continue. So here I copy. Yeah. So this slide, if you copy, same thing. I have it. Have them. Okay. Yeah. Yeah. All right. There, but to do the calculation, yeah, x times that. So let's do another round. Okay, x times y double prime. We just change the exponent for each term. Okay, yeah. Add 1. Yeah, add 1. All right. There minus. Yeah, so we multiply minus 1/6. Yeah, each term. That one. Okay. Yeah. There. That parenthesis plus 1, we can split. Okay, that 1, the first term, yeah, first term, we need to minus 1. Okay, yeah, the x power minus 1. Yeah, the second term, yeah, we copy down. Okay, second term, yeah, so just copy. So that 1. So I make this second one 1. So you just copy. Okay. So you split. So you write in a split way. Then you copy. Okay. All right. Then the computation. So then the computation. Yeah. Yeah. Then the computation is like this. Yeah. All right. We do, summation term by term. Okay. When we add the coefficient of this term, is it 0? Yeah. Yeah. Because that comes from the initial condition. Initial. It has to be 0. Okay? Yeah. So, 4, 5 cancel out. If you add them up, if not 0, that means your computation must be wrong. Okay? So the first term, because that's our initial equation, we make our initial condition 0. All right? So the coefficient sum of the must be 0. Okay? So the first is gone. Okay? All right. All right. Then the second. Okay? So you need to add up the minus. Yeah. So the plus. So, all right. So here, so I just calculate 1. Okay. The remaining you calculate carefully. Okay. So 2/9, that's 4/18, right? 4 says 9, 1/2. Well, good. It's a good number. 1/2 A1 plus A0 equals 0. How about that? Okay? So the second term we have, yeah, so if I'm calculating correctly, equals that, right? Yeah? Okay? Yeah. All right. So A1 equals negative 2a0. Yeah. So that's from the second term. Okay. Then third term. Okay. Third term. Yeah. You know. Yeah. Here. Okay. Yeah. So a2. Yeah. So 1/9. Right? 3. Right? Is it 3? Yeah. Because this one, you know, negative 2/18. That's negative 1/9 minus 1, 27. That's 3. 3a2 plus a3, a1 equals 0. Okay? Yeah, so the next one, 3a2 plus a1 equal to 0. So a2 equals negative 1/3 a1. Then we use the, you know, the previous one. So 2/3 a0. Yeah. So can you get that? Yeah. All right. Yeah. So that's this one. Yeah. So then the remaining, you know, so here, one more. So we're done. Yeah, because we already did this one. The last one, you know, calculate. Last one. Yeah. So this, you know, negative 5/18. Negative, you know, yeah. I mean, whatever, yeah. All right. So after you get that a0, you factor that a0 out, so the, you know, remaining inside. Yeah. So you can write. Yeah. Calculate the inverse Laplace transform. Yeah. Here, let me do. I may like to do 2 examples here. Yeah. The first one. Inverse to this fraction. Yeah. For a question like this, first we want to decompose the fraction. Yeah. Decompose. Yeah. Yeah. That's based on my experience with communication with you. I feel this part relatively weak for you. Yeah. Because most students, you only know to do the, you know, partial fraction, right? Partial fraction, yeah. So here, yeah, so you can still do partial fraction, but if we have a faster, easier way, then we try those better ways first. Yeah. All right, so here, I do not want to do partial fraction. Yeah. Here, let me show you the you know, technique to split this fraction. Yeah. All right. First, the denominator, let's factor s squared out. Yeah. So now this structure actually pretty easy to split. Yeah. But one thing special is there is s squared here. Think about if it's s, is it much easier for you? No s squared. Okay. If it is s, then because we did split of this type many times. Yeah. All right. Now, in our textbook, we have a formula like this. Yeah. So you can use this formula directly, because if you use this formula, you do not need to split, right? Yeah. So 1 over parenthesis s minus a s minus b, and this side just use this formula directly. Although you can derive this formula by split, then some other basic formulas. Yeah. But here, we can do a little faster. All right. But here, we cannot apply the formula directly, right? S squared. So we try to change the form, and after the change, then we can apply that one. All right. So let me show you. First, I take out one factor, 1 over s out. Okay? I just, you know, take it out. After I take it out, then I have 1 over s times, you know, the second one, right? Yeah? But you have to do something. You have to do something. All right. So here, I do this way. Look at this step, this split. this split. Can you see the split? So 1 over s, I keep it. But inside the bracket, I do the subtraction of these two fractions. But if you, after we do the common denominator, the numerator s minus 2 pi, there is a 2 pi. 2 pi, so that's why we need to divide 2 pi at the denominator. Can you see that? Yeah? Yeah, so this step, yeah. All right, in this numerator, you just imagine you need to do s minus 2 pi. But this after cancellation, you get 2 pi. Yeah. Numerator, you have a 2 pi. You have to divide 2 pi at the denominator, cancel out. You get a 1. Yeah. You get a 1. Yeah, because here we have 1. Right? So you have to balance. Yeah. Numerator, denominator. You have to balance. All right. After that, after this bracket split, yeah, then we multiply through. Yeah. So we have two terms. Multiply through the first fraction, second fraction. Okay? Now you can see if we do inverse Laplace transform each one, we can handle by appropriate formulas. Now we can apply appropriate formulas to calculate each term. Yeah. So let's take constant out because Laplace, inverse Laplace transform. Yeah. So here, the second term, we need to use this formula. The first term, that formula, right? Two formulas. The first one ready for this form, right? Yeah. The same. S minus 0, S minus 2 pi. How about that? S minus 0, S minus 2 pi. Okay? All right. All right. Now we calculate. We are ready to calculate the original inverse Laplace transform. Okay? All right. Then take out that 20 constant. Yeah. Then split. Yeah, this split. Okay. All right. This split 20 over 2 pi. So that's 10 over pi. Inverse Laplace transform. Okay? 10 over pi inverse Laplace transform. Okay? Now apply formula. Okay? Apply formula. Yeah. When we apply formula here, using our formula number 11, yeah, 11. Here I took the screenshot from table section 6.9. Yeah. In our chapter 6, last two sections, all formulas. Yeah. 6.8 formulas, 6.9 formulas. Here I took the number 11 from 6.9 table. It's a big table. Yeah. So, all right. So here, but when we apply the formula, we may use A as a larger number. Okay? Because A minus B, if you want to make it positive, right? A should be larger than B, right? Yeah. Minus 0, minus 2 pi. So probably you like to put the A 2 pi. Okay? E to the 2 pi t minus 1. Okay? E to the 0 times t. Yeah. All right. So that, yeah. Because 1 over another 2 pi, right? B 2 pi minus 0, another 2 pi. 10 over another 2 pi. So 5 over pi squared. 5 over pi squared. Okay? Inside the parenthesis, e to the 2 pi t minus 1. Okay, the formula. Okay? Yeah. Basic formula. Yeah. All right. That's the first term. Yeah. Second one, 1 over s squared. Yeah. By formula number 2, it's 1. It's t. Yeah. It's t. Yeah. All right. So that is 10 over pi times t. Yeah. So that's the answer.
This is all times
20. 20 already we used here, right? 20 over 2 pi, right? 20 over 2 pi. So 10 over pi. So we carry that So that's the, typical calculation like this. Yeah. All right. Yeah. Yeah. Next week, when I do training, I will do training on applying the formulas. Okay. So I give you many simple fractions. They ask you to, inverse Laplace transform. Yeah. One by one. Okay. Yeah. Practice a few times, then you can put things together. Okay. Yeah. So we practice individual one, right? Practice this formula, that formula, a few formulas, then put things together. Yeah. Yeah. All right. So this is the first one, but remember I show you these examples because we're targeting on homework question number 3. But this example, the techniques we used here, still cannot completely cover the techniques used in that number 3. So I give you a second question. Another one, calculate this inverse Laplace transform, then, just give you, the remaining techniques you need. All right. Now let's calculate this one. Yeah. The fraction, we split the denominator first. S squared times S squared plus 1. Yeah. But this time, let's split. Yeah. Inside parenthesis, numerator S plus 1. Yeah. We take it out. Okay. Then we split the fraction like this. Yeah. Yeah. Common denominator, the same as before, but if you do subtraction, the numerator, that's 1. So we do not need to do any adjustment. No adjustment for this one. Yeah. All right. After that, multiply through, like that. But we want to do further split, right? So 1 over S, because we want to apply basic formulas. 1 over S squared. Yeah. So 4 terms. Then we need to find appropriate formulas for each one. Okay? Yeah. All right. So then, inverse Laplace transform, we need to find these 4 simpler Laplace inverse transform. Yeah. Now, 4 formulas we need to use. The first one, 1 over S inverse, it's 1. Okay? 1 over S inverse. So we find formula number 1. Okay? Yeah, it's 1. Number 2, 1 over S squared. 1 over S squared. It's T. Yeah. Okay? Number 13. Yeah. 1 over S squared plus omega. This the last one. 1 over S squared plus omega squared. Omega is 1. Okay? Omega is 1. That's sine. Sine omega t over omega. Number 14, S over S squared plus omega squared. Yeah. That's this one. Yeah. So we just, apply these 4 formulas, we get these 4 terms. 1 plus t. This one cosine. Yeah, omega is 1. Okay, cosine. Cosine omega t, so cosine t. Minus 1 over 1 sine omega t, it's sine t. Yeah. Yeah. Simple formulas. Yeah. Yeah. These simple formulas, because we use a lot. Okay, all these formulas we use a lot. Yeah. So after you practice a few times, then when you see those terms, because we use so many times. Yeah. Almost all questions we need to use these formulas. Yeah. Almost every question we need to use these formulas. Yeah. Yeah. So then, yeah. All right. So that's our homework question number 3. Okay? Yeah. All right. Yeah. So then, number 4, yeah. Number 4, we need to solve an initial value problem. Yeah, so this one. The right-hand side function is a piecewise function. We need to write it in a friendly form. Yeah, friendly to Laplace transform. Yeah, using the Heaviside function. Okay, unit step function. So the R of t function at the right-hand side equals a times sine t bracket u of t minus u of t minus pi. Yeah, because the interval left end 0, u minus 0, okay, right end pi, u of t minus pi. Yeah. Difference. Yeah. That's the way we represent, 1. Yeah, so here, the 1 times 1, but only takes 1 on this interval. So that's how we write that. Okay. Yeah. Next, we need to calculate Laplace transform. Yeah. All right. Here, the left-hand side, y double prime. So we need to use the double prime formula, Laplace transform of double prime formula here. Okay. Here, initial value is given. Okay. Yeah. So we apply the second formula. The first one, we don't have the y prime term, so we don't need to use the first formula. The second formula. Okay. All right. Then, Laplace transform on y double prime, yeah, because initial value y of 0 is 0, it's gone. Okay? F of 0 this is gone, but second one non-zero, minus 4. Okay? S squared Laplace transform y minus t, minus 4. Okay. Yeah. Yeah, so if we use capital Y, represent Laplace transform. S squared capital Y minus 4, left-hand side. Now let's calculate the right-hand side, Laplace transform. L, Laplace of R, yeah, 2 terms. Yeah. Constant, take constant 8 out. Yeah. Now we need to calculate Laplace transform of these 2. Now let me show you. Yeah. The first one easy. Although you have u here, yeah. Let me use copy the formula here. Yeah, not this one. Yeah, look at this formula. First shifting, right? First shifting theorem. Yeah, this is formula. Yeah, we also use a lot. Yeah. In this formula, you only look at the first term. A equals 0. Yeah. You cheat. A equals 0. Okay? Yeah. A equals 0, e to the 0s, that's 1. 0 times s, that's 1. All right? Then, yeah. So you only need to take Laplace transform of f part. Okay? U part is gone. Okay? U part, because it becomes 1. It's gone. Okay? All right. And Laplace transform of sine t, we have this formula. Sine t. Okay? Yeah. Omega is 1, sine t. Okay? So that is 1 over s squared plus 1. Okay, that's first term. Oh, what's that? Window updating. Yeah, I don't need it. Tomorrow, yeah. Ask me for update. Yeah. All right. Yeah. That's the first. Let's write first result. Then the second. Yeah. Oh. So here, all right. So here, before I write the result, so here, all right. So here, right, yeah. The second one, the first one, yeah, we just did it. But the second one is a little hard. The second one, why? The second one, if you look at the structure, we cannot apply this formula, okay? This formula, you have to ut minus pi, but here, you also should have t minus pi that you can apply. If you don't have t minus pi, you cannot apply. Okay? So we need to do So here I change sine t to sine t minus pi. Can you see this sine t equals negative? Yeah, I change the sign. Okay, I change the sign. All right. Here we need to do this. Yeah, this step important. Yeah, let me show. Yeah, and in your homework assignment you have a similar step like this. Yeah, similar step like this. So this technique is, important. All right. So here we have sine t, but our goal, we want to get a sine t minus pi. But the question, what is sine t minus pi? Do you know it? Do you have an idea how to calculate sine of t minus pi? Yeah. First, yeah, basic trigonometric, no identity. You cannot be an identity. T variable. Right? All right. So here, first, sine. Let me ask you. Sine negative t equals what? Sine negative t. Sine function. But I use negative t. Odd function, remember? Sine function, odd function. Odd function, negative. Negative equals, you take negative out, right? Right? So here, negative, can I write negative sine pi minus t? Yeah, because sine odd function, right? So negative inside, take negative outside. That's the odd function. Even function, negative gone. Okay? So you don't change the sign. Even function, you don't change this sign. You just, switch, flip, pi minus t. That's even function. Odd function, you need to put a negative sign. Okay? All right. But negative sign, next question, what is sine pi minus t? Pi minus t. Quadrant. There, look at the quadrant. 0, pi over 2, pi, 3 pi over 2, first quadrant, second quadrant, third quadrant, fourth quadrant. Now, pi minus t, you look at the sign of sine function in second quadrant. What's the sign? What's the sign of sine? Sine function. Plus, minus, sine function. So second quadrant, the sign is plus. So it's sine. Then pi minus t, you do not switch. You use the same function. So that means still sine t. Sine t. If pi over 2 minus t, you need to switch function to cosine. Okay? All right. So here, sine pi over 2 minus t, you need to switch to, cosine t. But pi minus t, you do not switch. Okay? You still use sine. Yeah? I mean just the basic trig properties. Another way, so here I give, because here a lot of basic knowledge of trig. So probably you get, if you didn't practice much before, so probably for your heart. So one easy way, do you know there is a formula sine difference of two angles? That formula? Do you remember? Yeah. Right. Yeah. You just use that. Okay. So here, let's apply the sine formula, difference of two angles. Okay. Yeah. This one equals sine t times cosine pi, right? Minus cosine t times sine pi, right? What is cosine pi? -1. Yes. Sine pi 0, right? So second term is gone. the first term negative 1 equals negative sine t. Yeah, so, both ways. Yeah, second way probably easier for you. Yeah, because first way you need to use a lot of basic knowledge. Yeah. Quadrant, sine, all those things. Even odd function, all the knowledge put together. Second one, just one formula. Yeah. All right, here I just want to let you know we can change from second term that form to this one. We intentionally want to make both functions the same shift, t minus a, t minus a, same shift. If different shift, then we need to do an adjustment. Yeah, all right, so this step, important, okay, all right. Now, the second term we can apply formula, right? Yeah, the second term we can apply our first shifting theorem. This is our first shifting theorem, right? All right. Now, let's apply this first shifting on the first term and the second term. Okay. First term, easy, yeah. Easy, yeah. Just 8 over s squared plus 1. Okay? Yeah. Because no e part. E part is 1. Okay? E part is 1. But second one, a. A is pi, right? Pi equals a. Yeah. So we need to replace little a by pi. Okay? So the numerator, other than the constant a, you have e to the negative pi s. Then denominator the same. That's how you apply, inverse Laplace transform. Yeah. So this question, I want to show you this special, step is for the second term. Second term. Then our homework question, you will see. Yeah. Now I'll show you our homework question. It's not sine cosine. Okay. It's not sine cosine. It's different. But in our homework question, you need to do the Laplace transform of t squared times u of t minus 1. Do you know how to do it? T squared times u of t minus 1. Yeah? See? It looks simple, yeah, but, what formula to use? T squared. Okay? U t minus 1. Do you want to make the same shift? Yeah? If you want to apply this formula, you should have t minus 1 there, right? Yeah, t minus 1. Not t. Okay? All right. So what you do is, because in your mind, that's your goal. Okay? T minus 1 squared. That's your goal. So what you need to do, you need to represent t squared equals, how about t minus 1 plus 1 squared? How about that? So you force it to have t minus 1, that shift. This one, you have the t minus 1 squared formula plus 2 times t minus 1 plus 1. Then you have 2 t minus 1 terms. 2 t minus 1 terms. Yeah. But each one you know how to do it, right? Each one. That's a homework question. Number 4. After you take derivative, you have t squared. So you look at question, right? Because 1/3, 3 cubed, you need to take a derivative, right? Yeah. Is it that? Yeah. Oh, yeah. Oh, not that one. Yeah. Well, probably I'll talk about number 5, derivative. Yeah, not number 4. Yeah. Number 5. Yeah. Okay. Yeah. Yeah. Anyway, one of our homework questions. Yeah. 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 Because that one, after you take derivative, you have t squared. Okay. T squared, before you apply formula, do this step. Okay. Then t minus 1 squared times u function. The second term, constant you take out, t minus 1 times u function. Yeah. So you need to apply this formula twice. Okay, one. That shift t squared. T squared formula you can find, right? Yeah, t squared formula you can find. T formula you can find. Okay. Yeah. Any question? Yeah. Any question? If you still feel hard, so then next week we practice. You know, all these things, we do a few rounds practice. Yeah. You know, make you feel, you know, not so hard. Yeah.
So are you plugging that entire term into? So you do a loss of t minus 1 squared plus 2t minus 1 plus 1.
Right. 3 terms. Split to 3 terms. Yeah. All right. So this one, after that, we have t minus 1 squared u t minus 1 plus 2 t minus 1 and plus u t minus 1. Okay, yeah. Then each one you can find appropriate formula. Okay? This one, you know, this one, you can still use this formula, but f is 1. How about that? Okay? F is 1. All right? So e to the here 1 minus s. F is 1 over, yeah, F is 1, we use that formula, 1 over S, okay? Yeah, so you have formula. Here, the T, yeah, you know, e to the minus negative S, but Laplace transform of T, okay? 1 over S squared, 1 over S squared, all right? So T squared, you know, yeah, 1 over S cubed, but there is some constant. Yeah, you need to multiply in it. Constant 2, yeah, probably. We also have that formula. 2 factorial, so that's constant. Yeah. So each one you can find appropriate formulas. Yeah. But if you do not split, if you do not use this way, which formula to apply? So you cannot find right formula. If you do not do this change, you know, this, you cannot find appropriate formula in the table. Think about that. Yeah. It looks still puzzling. Yeah, not. Jenny, do you feel okay? Jenny, split like this?
Yeah, I see that.
Yeah.
Yeah, that makes sense.
Yeah. Yeah. Okay. Yeah. That's the relatively hard part. For other terms, pretty straightforward. Other terms, yeah, you know, after you split, you can find the formulas. But this one, you need to do this step. Then you can apply formulas. Okay? Yeah. 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 So here, similar, but we do sine. We do on sine. Okay? Yeah. Yeah. All right. Yeah. So this question. Yeah. All right. Yeah. So then we have this. We need to solve for y, capital Y. Yeah. So next. Yeah. So you can see after that we need to do inverse of y. You know. Still a lot of work. Okay. Still a lot of work. Inverse. Okay. All right. Here we want to work on this term. We split that term. Can you see this split? This fraction? Difference of these two fractions. Can you see that? Yeah. here you can see for this type of questions, we need to do fraction split a lot. So that's why you need to practice a lot for fraction split. Yeah. At least you need to feel very easy you can split this fraction. Yeah, but difference is 8. So we have 8. The difference is 8. So we do not need to do any other adjustment. You take the difference. That's all we need. Just take the difference. Okay? Yeah. All right. So the middle fraction is that. The first one we can apply formula. So we feel okay. The first one, just adjust the constant. We can apply formula. All right. So the inverse Laplace transform. Oh, sorry, I forgot the inverse. Yes. Here, because each one I need to put the inverse. Yeah. All right. We have 5. Yeah. Yeah, because after I split, some term we can combine. Yeah, actually, yeah. So here, split. Yeah. Yeah, because second we get 2. Third we also get 2. So 1 plus 2, 5. But this term we can combine. Okay. So before we apply any formula, we can combine. Yeah. So 3, I put it inside. Okay. After 4 minus 1, you get a 3. 3, because 9 is 3 squared. Okay. If we put 3 here, there is that sine formula. Sine omega t formula. Okay. Here, sine omega t formula. Okay. Shift. Yeah. Same sine omega t, but there is a, minus a shift. A equals pi. Minus a shift. A equals pi. All right? All right. So here, first the sine formula. Okay? First we apply sine formula. Oh, sorry. I need to use inverse. Yeah, I forgot. So this Laplace transform, I forgot to put inverse. 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 I forgot to put it. Yeah. All right. Yeah. Then sine 3t, sine t, sine t, but remember this e term by that, yeah. So the formula I didn't copy. Yeah. So the formula shift by pi. Okay. Also shift by pi, but t, remember t minus pi, we need to simplify it. It becomes negative sine t. Simplify it. Okay. Sine 3t minus 3 pi, we simplify it, also negative. 1/3 sine, yeah. So that's the final answer. Final answer. Okay? Yeah. That's all you need. Yeah. So, yeah, I copy this formula here. Okay? Yeah. So you can still apply this formula here. Yeah. Right. Yeah. Yeah. So right. Oh. Here. Yeah. Yeah. Think about, so if you can handle the calculation like this. Yeah. So we need to do practice. Yeah, think about, if you're not familiar with calculation like this, in the final 2 hours, then you will run out of time. Think about. It's very easy, you'll run out of time. Okay? So that's why next week, the 2 training session, very important. Yeah. Yeah. So we want to make ourselves, we can do calculation, this kind of calculation, just normal speed. Okay? Yeah. Yeah. Yeah, so then in that 2 hours, so you won't feel very hard. Yeah. 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 But we can target like this. Think about, can you use, let's say, between 15 to 20 minutes, about that much time. You know, between 15 and 20 minutes, if you can solve a question like this. Yeah. Yeah. If 15, that would be great. You know, if a little more than that, 20. Yeah. Because the first 2 questions we want to save some time from the first 2 questions. Okay, then a little harder. This one, yeah, you may need to use a little more time. You saved from the first question, first or second. Yeah. All right. Yeah. Okay. That's that one. Yeah. That's the solve, right? Number 13. So 0, 1, 2, 3. Yeah. So that's the, yeah. Yeah. 2 more questions, you know. Yeah. That's what we left last time. Yeah. That's what we left last time. Today I have 2 new questions. Yeah. So after I finish that Fourier, fast Fourier transform, then I talk about those 2 questions. Yeah. Here I think I can get out